Hello. In the previous section, we learned what Darwin Core is and how to clean our data. Now we need to learn how to format the data so it's ready for publishing. So Darwin Core requires you to format your data into core and extension tables. And depending on what kind of data you have, you might have a different arrangement of core and extension tables. You could have occurrence only for your core, you could have occurrence core plus extensions, or you could have event core with an extension. But because this topic is a little complicated at first, let's move to a more visual example. So as I mentioned before, core and extension data tables are like separate spreadsheets, but they're linked through the use of identifiers, and we'll circle back to identifiers. Let's take a look at what kind of core tables we can have. I've already mentioned occurrence and event core, so how do you know which one to use? Well, occurrence core is used when you have only data on an observation or the specimen. You don't have any information on the sampling info or how a sample was taken, and any measurements that were taken on an individual level, not at the whole sample level. Occurrence core is also used for DNA-derived data. Now, what if you do have information on sampling? Then you would use event core. So event core is when you do have information on how the samples were taken. So let's say you went on a boat and you took samples at different locations. This is when you would use event core because there are distinct sampling events. So then you might have measurements on a whole sample or the sampling methodology, and you might also have measurements that are abiotic, so temperature, salinity, and so on. Just as an aside, occurrence core is also frequently used for museum data and museum specimens like these mollusks here. So that's for our core tables. Now let's take a look at our extension tables. So for OBIS, you can have three main types of extension tables currently. So there can be an occurrence extension. So this would be used in conjunction with the event core, and it would contain all of your information about the occurrences you found, the specimen, the observation records. And then there's the extended measurement or fact extension. And this is used to include all measurements or fact. And finally, there's the DNA-derived data extension, which will be covered in a different section of this workshop. So let's focus on the extended measurement or fact, or the EMOF extension. So in this data table is going to be where you have all of your measurement data. And this measurement data links back to your event or your occurrence tables by use of those identifiers. So if you have a measurement related to an occurrence, you're going to have the associated occurrence ID. If you have a measurement related to an event, then you're going to use the event ID to point back to that sampling event. Now, it's important to know that records and measurements are documented a little bit differently than you might be used to in the EMOF. So you might be used to having a separate column for each of your measurements, a column for length, a column for abundance, and so on. The EMOF instead populates all of this data and condenses it into 3 fields. So you have a column for measurement type, measurement value, and measurement unit. So for this fish example, you would have measurement type, it would be length. Measurement value would be however long the fish was, 15, a measurement unit, and centimeters, inches, whatever your unit is. And there might be other fields that might be required. And this is covered a little bit more in the workshop page. So you might also be thinking, well, there are many different ways to document and write down what the measurement type is. You could write length, you could write total length fork length, snout length, fin length, and so on. So how do we account for all of this heterogeneity? This is where the use of measurement IDs come in. So you'll have a measurement type ID, a measurement value ID, and a measurement unit ID. And these are used to account for the heterogeneity. Now, the details of choosing and finding a measurement type ID is a little bit outside of the scope of this workshop, but we do have some guidance and some links on the workshop page. So as I mentioned before, there are the identifiers that link our core and our extension tables. You have the event ID and occurrence ID. Now let's take a look at an example to help solidify this conceptually. Let's say you went and took a water sample, and in this water sample you had temperature data. You took a temperature measurement, and you also have the species presences, species occurrences. So the first thing we need to do is decide what is our data set structure and what is our core data table. Is it occurrence core or is it event core? Well, because we have information on how the samples were conducted and we have abiotic data, we're going to use event core. So this is a small snippet of what our event table might look like. You would have the event ID for each unique sampling event, the event date, and you would definitely need to include the decimal longitude, decimal latitude, and all other information related to the event core table. So now what about our species presences? Where are we going to put this occurrence data? That's right, the occurrence extension table. So you'll notice we have the event ID, occurrence ID, and the scientific name. And you can include, of course, all other information related to your occurrences. But we'll see that these two species have different occurrence IDs, but the same event ID. And this is because they were found in the same sampling event, but they are, of course, different specimens. Great, so now we have to figure out where we put our temperature data and the measurements, for example, we took on these species. So where we're going to put that? In the EMOF, the extended measurement or fact extension table. So on this first line here, we can see our event ID points back to a sampling event. We don't need an occurrence ID because this measurement is not associated with an occurrence, just the event. So our measurement type is temperature, our measurement value in this example is 25, and of course we would need to include measurement unit and then the associated IDs. And for the second row, we have the same event ID that came from the same sampling event, and it points to this first occurrence ID, first species here. And we have, again, our measurement type. In this case, is length, measurement value, 15, and then same thing I just said, we'll want to populate the rest of the columns for unit, and then the 3 associated IDs. So hopefully that helps solidify your understanding of the OBIS schema and how core and extension data tables are linked. Let's go back to our workshop page. So we have lots of information that I've just covered. We have a couple exercises for you to go over. And finally, I just want to touch on what is an ID. We've been talking about IDs and identifiers this whole time, but like what actually is an ID and how do you make an ID? So the identifiers is a unique identifier that points to an event or an occurrence, a specific record. So how to actually build these identifiers, there's no standardized way to build or come up with an identifier just yet. So what we recommend is building your identifiers from the information in your data set. So you can concatenate the name of the station, the date, the species, the name of the project, and concatenate all this information to create a unique identifier. And really the main thing is that these IDs should not change over time. So if you are concatenating it based on some information that might change, maybe leave that information out of your identifier, so that way it doesn't lead to confusion down the line. So just to summarize, Darwin Core uses core tables and extension tables. These tables are linked through the use of identifiers, which are very important. And by structuring your data in this way, it helps to make sure no information is lost. So, thanks.